Hello, and welcome to a video about estimating regression parameters. Before we start, in order to fully grasp the concept of this video, we need to establish the simple linear regression model. The simple linear regression model explores the relationship between a quantitative response or independent variable and one or more explanatory or dependent variables. The most straightforward way to estimate this is through understanding the variables in the formula. The linear regression model is defined by the following formula. The dependent variable, in this case y, which is equal to beta initial and beta 1 times the independent variable, in this case x, plus the error component. The relationship between betas is important in order to be able to understand a graph. You can think of beta initial as the y-intercept of a Cartesian graph and beta 1 as the slope of said graph. Another key aspect to estimating regression parameters, and arguably the most important one to engineers and businesses, is the coefficient of determination, or R squared. The coefficient of determination is defined as the variation between a regression parameter and the actual relationship between x and y. It will basically establish how trustworthy your linear regression parameter is. The higher R squared is, then the more accurate our regression model will be. The lower the coefficient, the least likely you are to follow the specific model in front of you in the real world. As an engineer, tools like the coefficient of determination are key to our profession, as several of our projects will put people's lives at risk, and we will need tools like these to scrutinize the relationship of two variables and be as precise as possible. An example of this would be when working in a big project with multiple variables that have to come together, in which you usually have a very small margin of error. The coefficient of determination analyzes a regression parameter's efficiency by analyzing the accuracy of the relationship it establishes. I know that was a lot to take in, but here's an example. For aircrafts, the type of material used in all parts is crucial. Density and weight are key in calculations and will directly affect an aircraft's performance. A good example of a regression model would be to attempt to establish a relationship between the weight to density and toughness ratios for different specific materials, to strive to use the one that fits into your specific calculations. Thank you for your time, and I hope you found this video helpful.